Okay, the goal of this problem is to go and rewrite this second order equation as a system of first order equations, and it's actually a fairly simple process. The first thing we're going to do is pick a brand new variable to represent y prime. So it's common to let x equal y prime, and then if we take derivatives, we have x prime is the same thing as y double prime. We can now go and rewrite our equation using these variables. So our y double prime is replaced with x prime. The y prime is replaced with simply x, and the 4y stays the same, and that's still equal to 3 times the cosine of 2t. We can now take this equation and solve for x prime. So that x prime is equal to negative 2x minus 4y plus 3 cosine of 2t, and we still have our y prime equal to x. We can now rewrite this in a matrix form as xy as a vector prime is equal to a 2 by 2 vector of negative 2, negative 4, negative, well, not negative, positive I should say, positive 1 and 0 times the functions x and y plus a 2 by 1 matrix which has 3 cosine of 2t and 0 as a placeholder. We can then generalize this in a vector form as x prime is equal to a times x plus f, where the f and the x prime are vectors and x is shorthand for xy. For our initial conditions now, if we go over here, we will notice that y of 0 is still equal to 1, but now remember that our x prime, or our y prime, is the same thing as x. So instead of y prime of 0, that's actually x of 0 that's equal to negative 2. So as initial condition, we would write that x of 0 and y of 0 in vector form is equal to negative 2 and 1. So again, we have our matrix equation down here, and we have our initial condition expressed as a matrix over here. And we've expressed our second order as a system of two first order equations.